Okay, so how many of you were at the keynote right before this? Okay, I feel the pressure because Dylan is fantastic. He's a fantastic speaker. He's witty. He invented his own freaking programming language, which you can sing. I can neither sing nor have I invented a programming language. Now, but he had some excellent tips. For example, to get a conversation going, ask someone what they are working with. So my teenage son actually tried that on me. He said, "Dad, what are you actually doing when you're sitting at the computer all the time?" And I said, "Well, I do build login systems. So I build login buttons." And you know, that is where the point where the one asking should encourage the person to continue speaking. My son was like, "That can't be hard." And then that conversation was dead end. But I'm from Sweden, and Swedes, we are not exactly known to be the most encouraging people, maybe. So I'm very happy to be here in Denmark. Every time I just get over the bridge, it's like another world opens. It's clean, it's nice, it's warm. There are people riding bikes, walking everywhere, instead of just the car-centric Swedish culture. So, well, I love being here in Copenhagen. Thank you for having me. And thank you for letting me in. This person here actually didn't get in. He had a problem at the border check. Because I want to start with, when I created this talk, I figured out that I could just call it ASP.NET Core Auth to be disambiguous between authentication and authorization. But I made up my mind and said that no, I should probably be specific. So let's see. This guy has a problem, but there are two different scenarios. In the first scenario, he presents a passport where the photo doesn't look like you, and you're not 155 centimeters. Nice try, but no, we won't let you in. And the second scenario is that, well, it is a valid passport from Faroukistan. The picture matches and everything. It's obviously him, but it's honest. But no, we won't let you in because there's an embargo for Faroukistan citizens. One of these is authentication, the other is authorization. The first one, which is it? Authentication, yes. A failure to establish who the people. The first is about establishing who the person is. The second is about, once we know who they are, what are they allowed to do in the system? In ASP.NET Core, this is a three-stage process. First, we have the authentication step happening, and regardless how authentication is done, it ends with setting HTTP context of the user. So in the rest of the system, the rest of the request pipeline, we can just check HTTP context of the user and know that it is the information about the current user, and we can use the we can write authorization rules based on that. Let's start with authentication. Interacting with the authentication system in ASP.NET Core, there's an iAuthentication service you can call and inject, but there are also convenience extension methods on HTTP context. But there is a core set of abstract API methods that can be used for all different ways of authentication. So I want to start with this, and this is really, the reason I want to start with this really comes from my experience as a consultant at Duende. So Duende Software, we build identity server. I work with authentication solutions for a lot of organizations. And I can see that about half of our support issues and half of our consulting calls are really about a few very fundamental things that if you get those wrong, things just break. So I'll try to condense those basic things into this talk to see that if you have attended this talk, you should be ahead of 50% of our support requests. So first one is about what is the actual API to use with the authentication system. The first method, well, if we build an authentication system, we might have a method called Authenticate Async, but what does it really do? And you know, naming is hard. When I first saw this, I thought that, well, this is probably about logging in or establishing a session or something. It's not. This is about querying the request about, is there any information? Is there a session cookie? Is there a bearer token? Something on it. Do we know who you are? If we don't, we can challenge. Challenge is a signal to the authentication system that, hey, we have a user here. We don't know who they are. Can you please sort that out for us? So the typical flow is that we first call authenticate async. We don't get a result back. That we then we call challenge async to initiate sign-in. Eventually, there will be a call to sign-in async that establishes a session somehow. And there's obviously sign-out, which is the other way around. The final API is forbid async, which is the access denied page, or saying that we know who you are, authorization failed. We know who you are, but you're not allowed to do this. And these are abstract methods that work across different kinds of authentication methods, so that remote authentication, cookie-based, zero token, APIs, all of them can just use the same API surface. Let's start by looking at cookies. So authenticate async, what would it do if we have a normal server-side web application with a cookie-based session? Well, authenticate async just validates the cookie on the incoming request. Challenge async. If you challenge a cookie to something, so the cookie cannot conjure itself up from thin air, can it? No. So this not really good thing for the cookie handler to do. So what they decided to do in the design is that it redirects to pre-configured login path. So this is one thing that sometimes gets tricky, is that suddenly your system might redirect to /account/login, even though you don't have a /account/login in your application. You never entered that path anywhere. Where is /account/login coming from? Why is someone redirecting there? The answer is that it's the default login path of the cookie handler. So there was something challenging the cookie handler, and it redirected to the default path. And if you didn't put a page on /account/login, well, it won't work. Calling sign-in async on the cookie handler will create the session cookie. Sign out, well, remove, and forbid, finally, just redirect to the access denied page. But this is a great API because it's an abstraction. There's nothing in here that actually says it has to be a cookie. It could be something else as well. So for example, it can be a bearer token for an API. Authenticate async from an API. So for a cookie, authenticate async was all about checking the incoming request and decoding the cookie. We do the same thing for a bearer token. We validate the incoming token. Challenge is another thing. So the cookie authentication scheme is used in server-side web application where the client is a browser with an actual human being there. So we need to be nice to human beings. An API, on the other hand, is called by code, a machine somewhere. So how do we tell in the short form to code that, hey, you need to get your act together and attach something that we can make us validate your identity? Well, we return an HTTP status code. Anyone want to guess which status code could be challenged? 401, exactly. Just a 401. The API is the same across all these, but sign-in async, does it even make sense? No. An API is stateless. There is no such thing as a session. You just attach a bearer token for every API call. So sign-in async, not defined. Sign-out, not defined. Forbid. That's another HTTP status code. So if the first one is 401, what is this one? 403, exactly. You are not authorized. Then there's a bit of an interesting backstory here, because what is the name in the HTTP spec for the 401? Unauthorized. Back in the days when they wrote the HTTP spec, they were not exactly clear about the difference between authentication and authorization. So to attach a bearer token to an HTTP request to authenticate the call, you put it in the authorization header. This is from the same age where they spelled referrer wrong. You know, every HTTP implementation has to spell referrer wrong in the header, because that is how it's written in the spec. If you spell it right, it's not spec compliant. But regardless of how if it's a cookie that comes in, or if it's a bearer token that comes in with a request, once we have decoded it, validated, all of that that the handlers does for us, we need to set the HTTP context at user. And for a long time, I mean, I started doing web development. I'm getting old. It was the last millennium that I first wrote web things. And back then, it was fairly simple because you just had to click integrated Windows authentication, that checkbox, and then you had authentication working. And there was the HTTP context, the user property was populated, and the same with .NET. .NET came around a few years later. We had the user property was populated, and to me it was just pure magic how it happened, but it was populated. Then in ASP.NET Core, someone showed me the authentication middleware, the actual code that is responsible for this, and I was kind of disappointed. I expected some magic, and it looked like this. It calls authenticate async to query the incoming request about the authentication, and then if there is a result, it just assigns context as user. No magic. Now, I went ahead and looked at the system I was building. I had a login method, username, password, and then I started thinking, if I get to a new system that prompts me with this, I'm actually like, not another one. Okay, of course I have a password manager. Of course I have hundreds or thousands of passwords in my password manager, but I need to go and create another entry. No, I prefer sites that offer me this. I can just use one of my existing accounts, my favorite login provider. I can pick one to sell my soul to. And that adds to ASP.NET Core something called Remote Authentication Handler. So Remote Authentication Handler knows how to do the handshake between our web application and the upstream provider. Once it has done that thing, we need to establish a session. Because if we log in with Google in an application, we're not redirected to Google for every request, are we? No. We are redirected once, and then there's a cookie set. To set that cookie, well, the Google handler could know about cookies and how to set them, but that would be repeating the same functionality over again. So what it does is that it actually relies on the cookie handler the existing cookie handler to do that. So it just calls sign in on the cookie scheme, this cookie handler. So that way, if we want to add another upstream provider, well, there's still just one application cookie that looks the same, regardless. So let's look a bit about how a remote authentication handler implements the API. It's still the same API. Authenticate async, query the remote handler about the authentication state. No, it doesn't make sense. It doesn't carry any state. If you want to know the current state, we need to query the cookie handler. Challenge async, on the other hand, that is to initiate the sign-in. That makes sense. It redirects to the provider. Sign in? No, it doesn't make sense. Sign out doesn't make sign out doesn't make sense because we do not establish a session. Sign out, however, makes sense. So, some 15 years ago, I was working on one of my first projects where we actually did single sign-on. It was a Swedish healthcare project, and we had to use an upstream provider that used smart card logins, etc., for security for healthcare records. And we implemented single sign-on through an upstream provider using the SAML2 protocol, and everything was working. We implemented logout, so if you click logout, we just removed our session cookie in our application. And we thought that was fine, and then we got a bug report from a user. The user said that, hey, I signed into the application, I was working in the application, then after I logged out, and to verify that the logout actually worked, I went back and tried to click a protected link. And I was logged in still. Your logout is broken. Well, our logout was not per se broken, but what happened was that our logout worked in our application, but when the user clicked that protected link, they were immediately redirected to the upstream provider where there still was a session and they were single signed on back. So sign out async actually makes sense for a remote provider, because if to implement logout properly when we use an upstream provider, we need to be able to initiate sign out with the upstream provider too. Finally, forbid async. Well, no, that doesn't make sense. So that's the theoretical abstract part. Let's look at some code and how we set this up. The first call is to add a cookie, add cookie. What that actually does is that it creates an instance of the cookie options object, and it registers a cookie handler with the DI system. Then we might call add OpenID Connect to work with an upstream provider. It creates once more OpenID Connect options and the OpenID Connect handler. But then we need two upstream handlers. This is a multi-tenanted software as a service thing where we need to allow two different customers. They both have their upstream OpenID Connect handler. So we need to call add OpenID Connect again. Okay, what happens now? We already have an open OIDC options and OIDC handler. Well, it registers another instance of the OIDC options, and it reuses the same OIDC handler that we already have. And to keep track of these, there's a concept called an authentication scheme. And a scheme is defined as a named instance of the options object and the corresponding handler type, which is available through DI. So we can have a cookie scheme, an identity service scheme, and an Entra ID scheme in the same application. So now it starts to get a bit more complicated. So when we call these methods, we actually need to decide which one to call. So we need to specify a scheme. So let's take this. If we have an application that uses an upstream provider, it still has cookies to persist the session locally. If we call authenticate async, which one of the schemes should we pick? How many think it's cookies? How many think we should call authenticate async on the OpenID Connect scheme? And the rest of you, you're just waiting for someone else to answer. Okay, that's fine. We're still in Scandinavia, even though you are better than Swedes, but we're still in Scandinavia. So authenticate async, when we want to query the session, we need to call that on the cookie scheme. To challenge, well, we typically challenge the OpenID Connect scheme because the OpenID Connect scheme is responsible for performing the sign-in for us. Once that's done, we need to establish a session. That's the cookie scheme. Sign out is the only one where we need to do it on both schemes, because we both need to tear down our own local session and we need to instruct the upstream provider to sign out. And finally, forbid is best handled by the cookie handler. However, it's a bit awkward if we need to use a scheme name explicitly every time. So there is a system with a default scheme in the configuration. And this is one more place where I often see that people have the config has been is not correct, and this causes all kind of weird behaviors. So there is a default scheme that is used for all of operations if you don't specify something, but it's actually a default configurable for every single of these operations. And there's a fallback system. So if you don't specify the default challenge scheme, it will use the default scheme, the overall main default scheme. And the same is true for everything except default sign out, which falls back to default sign in, then falls back to default scheme. So we'll see this in demo shortly, where we can actually set different default schemes for different operations. But first, I want to revisit the authentication middleware, because I showed you the authentication middleware source code. That was a simplified version. This is what it actually looks like. It first checks what is the default authenticate scheme, gets the scheme name, so it knows that it's the default scheme of the application that it should call authenticate on. and use to set the context as user. Why not skip out of slides a bit and do some coding? So I have a small application here that I built that is running somewhere here in the background. So this is just this very simple application where I can register multiple authentication schemes and we can add login. So it's time, in this sprint, it's time for us to add authentication and authorization to this application. In the previous sprint, someone created the, am I not running this? So in the previous sprint, someone created the login page. So there is actually a login page here already. Let's see if it gets started. Yes, the login page. There is a login page. Anders password. Invalid username and password. Okay, Anders. Yeah, this is a strong password. I got redirected back to the start page, but it still says no authenticated user session, please log in. So something must be missing. So let's see, what do we have here? We have, in our program, we don't even have authentication wired up. So let's add that first. Builder.services, services.add authentication.add cookie. Make sure we have app.use authentication. And then let's go to see what the login page looks like. The login, let me see, action, login. So someone has already done a very secure, can you see at the back, is it large enough? Yeah. So someone has already made a very secure username password thing. And they have constructed a list of claims about the user so that we have information about the user, but they never got around to do the actual login. So let's do that. We know that we want to call await HTTP context.signin async, right? Sign-in async requires a principal. To create a principal, claims principal, we need to, when we create a principal, the principal is created around an identity. So we need an identity. Let's create a claims identity. Identity equals new. This new magic thing where it writes codes for you, and this new magic thing where it gets it wrong. Because this will not work. We can try and see what happens if we just try to trust AI. Because this is yet one more of the weird things with how the system, the ASP.NET Core works. I have no good explanation for this behavior at all. Let's try logging in. Anders. We get an exception. Sign in async when principal identity is authenticated is false is not allowed. I didn't set is authenticated, but I just expect that if I create an identity, it should be authenticated, right? So let's look up that thing, that method or property identity dot is authenticated. How is that one defined? It's defined as return not string is null or empty authentication type. And I mean, this is really, to me, just weird. But whenever we create an identity, we need to set an authentication type. And that's done here in claims, so it just sets password as the authentication type. There are a few more things that are good to set. One is the name type. So for historical reason, there is a property on claims identity called .name, which should return the name of the user. Now that we have claims-based identities, we want it to know what claim should actually be presented as the name claim when we call the name property. Similar with roles. So always use the for-param version of the claims identity constructor. So let's try to run it again. No authentication session, please log in. Hey, it says welcome Anders. So obviously the .name property works. I'm logged in. If I log out again, we can now actually try these methods and see what the API does to the cookie handler. If we challenge, what will happen? You think? The login page? Yes. If we call, maybe I should complete the sign in. Anders. No, I can't type my own name. So I'm signed in. Sign out, what will happen? Signing out. We can see the state, now it's signed out. Forbid, redirects to the access denied page. And authenticate. Well, I'm currently not authenticated, but if I am, I will get information. We can all now see that also that authenticate async, if we call directly, we get both the claims and we get the property bag. That is metadata about the property. So there is both the claims that describe the user, but also another generic property bag. We can see here that the cookie handler uses it internally for keeping track of the lifetime of the session. When was it issued and when does it expire? So let's see where I'm running. So that is what we have for cookie authentication. I think it's time to add another authentication method. I want to be able to use OpenID Connect authentication as well. So I'll just do add OpenID Connect. And then I need to set a few options. I could talk for another hour about what options to set on OpenID Connect, but that is not the focus right now. So I just have an extension method prepared, configure identity server. So I'll configure the OpenID Connect protocol to work with a demo instance of identity server that is available. But now I have two schemes. When I just had one scheme, that automatically is the default scheme. Now I need to tell my system what it should do for different things. So I can just set the default scheme here is cookie authentication defaults.authentication scheme. Running my application again, it allows me to do this is interesting. The contrast is weird. There are actually panels of shadowing here on my monitor, but not on that one. I try to do nice web design, and then the projector just ignores it. Thank you. So if I challenge the OpenID Connect scheme, that will send me over to the OpenID Connect provider to sign in. And I can now go and check authenticate and query what is the resulting session. Sorry, that is actually, I should of course authenticate the cookies. So I can see that I got a cookie created. I can also see that the property bag contains a lot more interesting things like an access token that we will later use to call an API. Okay, let's go back to that slip I did. I clicked authenticate on the OpenID Connect scheme. Does that make sense? No. But it's such a common thing that people would do. So the OpenID Connect handler just actually, if you call authenticate on the OpenID Connect scheme, it just forwards it to the sign-in scheme, the default scheme. So you cannot actually authenticate on the OpenID Connect scheme, but it will help you out. I think that is, I don't agree with them, because I think that this is a source of confusion. I think it would be better if this method failed on the OpenID Connect scheme, because that would make it more clear what's happening. They made the decision. So let's talk about sign out. If I do sign out on the cookies, it will be just like the application I had back in the days. If I click challenge now here, I'm automatically signed in because I didn't terminate the session on the upstream provider. So if I click sign out on the OpenID Connect provider, well, I'm redirected to identity server, and I can redirect back, but I'm still signed in on my application. So I need to sign out of both. Now I'm actually signed in, signed out. So I have a logout button here that does that for us. We can check the source code of the logout button. It is in controllers API controller logout. So logout actually starts by calling authenticate async to get some more details about the current session. It goes and checks the authentication properties for an auth scheme. Let's see here. Do we have that? Oh, I'm not signed in. Challenge. So we have the auth scheme here, OpenID Connect. So my code will go and check, okay, how did we sign in? Was this an external sign-in or just a local sign-in? If it was an external sign-in, we sign out of both. If not, well, we just sign out of the default. So that is how you need to build a proper sign-out, need to do both. So those are the APIs for a server-side web application. Let's continue with the next block of features that I wanted to present. I will have some time. I will have time for questions at the end. So once we have set HTTP context.user, then it's time to do authorization. And in ASP.NET Core, authorization is done through policies. So in the actual code, we just refer to policy name, for example, managed customer. And then we have a separate piece of code somewhere where we add authorization and define the policy. The interesting part is this, where we set up create a set of rules, require authenticated user, require claim that the department rule is claim is sales, and require role manager. This is, by the way, why we also need the role name type, role claim type properly set on the identity. If we don't do that, then require role will not work. And this is a very simple policy where we just use built-in requirements. It is also possible to define your own requirements. And there is a three-tiered architecture here where we can have a policy which is string over 18. You need to be over 18 to buy beer at least, or buy beer at the pub, at least in Sweden. Do you have better rules in Denmark? Okay, so I can safely send my teenagers here. They will not be able to have beer. That's good to know. Swedes need to be over 18. Okay, my kids are Swedes, so, but actually the oldest one is over 18, so then I'm okay, shit. We can express that as a requirement, and the requirement is just a data carrying object describing the requirement. Then we have handlers that actually evaluate the requirements. And this might not make sense in this simple scenario, but let's look at another one. Reading medical records or patient journals. Swedish legislation says that it has to be smart card login. That is one requirement. So we can have a handler that checks if the current login method was a smart card. And Swedish legislation also says that just because you've logged in and you're a healthcare professional, you cannot just go read anyone's medical records. You have to have a reason. You have to have some kind of relation, a booked time, or you're participating in the treatment of this patient. How can we find out that? Well, one handler could be to check the calendar. Is there an appointment? We could have a window saying that if this healthcare professional had an appointment with the patient the last week or will have an appointment within the next week, then it's fine, otherwise not. Then we have these things where, well, not all visits to the hospital are planned. If someone arrives by ambulance, you don't really put things in the calendar for that, right? So we might have another handler that checks is this an emergency. And this is actually a correct thing, that you can have multiple handlers that evaluate the same requirement, and there's a vote. If one of the handler votes no, it's a no. If one of the handler votes yes, it is a yes. So in this case, with the ambulance and the emergency room, probably the appointment handler would just say, no idea. It wouldn't cast a vote at all, and it would continue to the next handler, which would say that this is the ER, it's fine. This is a powerful architecture, especially if your handlers need to invoke other services that are available in the DI system, because the handlers are services in the DI. It's powerful, you can do whatever you need, but for most cases it's just overly complicated. So I want to show you my escape hatch, how to get out of the complexity. There's actually another built-in method which is called require assertion. That just lets you write some code. So require assertion, you have access to a context about the call, and you can, when doing this, you can decide if you want to return true or false. So actually we could bug fix. There was a bug in our previous implementation, because the previous implementation required the user to be a manager and have the user to have a department of sales, but the actual business requirement was that the sales department should all be able to, everyone on the sales department should be able to handle customers, and managers from all departments. So here we can express an OR expression using this. Let's go back to our demo and see if we have any authorization. Yeah, Alice is logged in. More details are found on our secure page. Here it says invalid operation exception of the authorization policy named top secret was not found. So obviously, in the previous sprint, someone set up authorization and said that there's a top secret policy here, but they never got around to, in that sprint, to implement authorization. So it's time to add it. The builder.services.add authorization services add authorization opt.add policy top secret p and p dot require authenticated user. Why not do a weird thing? Require assertion CTX. In CTX we can just do CTX dot user dot find first, or we can just identity dot name dot starts with A. So any user where the name starts with A will be able to log in. We also just need to handle the case if there is no name, if the name is null. Let's run it again. If I now click login, I can just log in with Bob. Secure page, access denied. Bob's got the wrong name to access this. Select Anders. It's me and Alice. Top secret, welcome Anders. So it worked. I've created my own custom policy that works. This is good, but if I'm not logged in at all, what will happen when I try to access this page? Well, the authorization system will automatically challenge, and it will challenge the default challenge scheme. But I don't want to use I don't want to have the challenge or the default to be the local login. I want the default to use my OpenID Connect provider. So let's fix that. If I go in here on the authentication setting, I can set the default challenge scheme, set it to OpenID Connect defaults.authentication scheme. So now I said that whenever the authorization system just challenges without anything, it will challenge the OpenID Connect flow. So let's run it again. I'll click secure. Authorization system finds out I do not fulfill the required authenticated user requirement. It says, okay, what do we do? They are not authenticated. Let's challenge. Go here. If I log in with Bob, I think it's lowercase Bob here. I will redirect it back. It tries the top secret page again, the secure page again. Now it finds out I am authenticated by Bob doesn't start with an A, so it calls forbid on the default scheme, and I end up on the access denied page. If I log out and click again and try Alice instead, I'm welcome. So that is the block on authentication authorization. I will continue a bit and talk about ASP.NET Identity, but before I do that, does anyone have any questions so far on authentication authorization? I will have time for more questions at the end. Sorry. So ASP.NET Identity, if you create an application in Visual Studio and select use individual user account, you will get the ASP.NET Identity system bundled in your application together with a bunch of pages. It looks like this. Use a local account to log in, or it has support also for upstream providers. I want to talk a bit about the architecture of ASP.NET Identity, because I find out that people often just add it and see it as a black box, but it's actually quite flexible architecture with that is modular. First of all, you get a bunch of UI pages. Many years ago, the UI pages were actually dumped as code in the template. So if you created a web application using ASP.NET Identity, you get hundreds of lines of code. And people were upset about that because they got tons of code that just was there for them. So Microsoft invented these Razor page libraries just because of ASP.NET Identity, where you could put pages into the actual into a library, a NuGet package. And then people were upset about that because they were stuck with Microsoft layout. So it's actually possible, if you add this, it's possible to still go in Visual Studio and select a scaffold and get the code into your application so you can fix the layout to look the way you want. The main service in ASP.NET Identity is the user manager, which lets you interact with the user store. The store is actually an abstraction. So you can plug in any storage method you have with ASP.NET Identity. If you have an existing database, an existing CRM system, you can plug it in if you really want to. I've never seen anyone do that. Everyone just uses the Entity Framework abstraction that stores it in a database. There's also another service called the Sign-in Manager. The Sign-in Manager both interacts with the user storage, but also calls sign-in for us. And ASP.NET Identity also mess up our authentication schemes. It comes with identity.application. So the default cookie scheme is now called identity.application. And actually, it has to be called that because it's hard-coded inside the sign-in manager. So if you use the ASP.NET Identity, you must use the identity.application name for the default cookie scheme, or things will not work. So that's one scheme. It actually also adds another scheme, identity.external. So what is that? Well, this is a clever pattern called the external login callback that is used for external authentication. So if we have an external authentication method, an upstream provider that is outside of our organization, it sends its result to the OpenID Connect handler. And this is kind of an integration. We are integrating identity. And in any code where we are doing integration with external partners, we do not allow data from external partners to go directly into our application, right? You should always check it, clean it, fix it, translate things before we allow it to go right in. So we don't want to allow the external identity from the external partner to go direct into our application cookie. So instead, we instruct the ODC handler to call sign in on identity.external, kind of quarantine area. It's the cookie, it's there, but it's not still, it will not populate HTTP contexted user. Then we redirect to external callback, which is a page that can show UI. It could, for example, see that, hey, you are a new user, you never signed up with us before. Can you please consent to our terms? Fill in our registration form. You can drive UI. You can create the user automatically in the database if it's a business-to-business scenario. You might want to see that, yeah, it's a new user, we should accept them. Let's create a user record. The external callback can call authenticate on identity external cookie scheme to get all the information from the upstream provider. It uses this user manager, sign-in manager, to eventually call sign-in on the default sign-in key to create the main application session. Call sign-out to get rid of the first set of cookie, the first cookie, and finally redirect to the target page. And now, as we have the identity.application cookie set, HTTP contexted user is populated. And the reason I want to bring this up is because I often see that when you configure external providers together with ASP.NET Identity, you need to get these schemes right with the external and versus internal application scheme. Another thing that ASP.NET Identity gives us is the idea that we have a user that might have one or more login methods. This is stored in the ASP.NET users table and the ASP.NET user logins table. And I think this is a good thing because it means that you can separate your definition of the user from the upstream provider's user ID. And this allows for easy migration between providers. It also allows, I mean, I never remember if I used Facebook or Google to sign up to a site, but if they use the ASP.NET Identity, I can connect both. So the next time I get to the site, I could use both Google and Facebook, and it will get me to the same actual user account in the application. So I will not add ASP.NET Identity to the application, I just want to talk about it. One final thing I want to cover is a mechanism called data protection. Data protection is a fairly low-level mechanism in ASP.NET Core, but it's used a lot by the authentication system, and it turns out that it's easy to overlook that you need that you should configure data protection, because if you're not using it directly, well, you shouldn't need to configure it, right? But actually you need. So what is data protection? If you have a piece of data, for example, a set of claims, and you want to store it somewhere untrusted, you can protect it. For example, you can have a set of claims, you protect them, and then you have the cookie payload of the session cookie. And you can unprotect them and get the payload back. This is a dead simple encryption API. How many here has tried to use the AES class directly in .NET? Initialization vectors. You need to create them, you need to keep track of them and not reuse them, or if you happen to reuse them, you break the encryption. Key management, you need to create keys. Key rotation, keys should have a finite lifetime. There's a ton of things to think about when using AES correctly. Data protection is doing all of that for us. For example, it creates keys and uses them, which means that somewhere there are encryption keys stored. And that somewhere is, well, ASP.NET Core does the best it can guess for you. It stores it in the user profile on Windows, if the user profile is loaded. So what if we run everything under my account and then we decide to change what account we run and everything on the server? Well, if the encryption key was in my account, then data is lost. If there is no user profile, it uses local disk. So what if we deploy to 2 load balance servers? Well, they will create a set of keys each on disk. So in any ASP.NET Core application, I recommend to always set up data protection explicitly. Call add data protection, set an application name. This is to prevent incorrect key reuse. The default application name it derives is the path of where the application is deployed. So if you just change the file structure, keys are lost. It's better to send an explicit name. We should be explicit to where we save it. For example, the file system, database, Azure Blob Storage, there are plenty of methods. Even Amazon provides a set of data protection libraries for ASP.NET Core where you can store the data protection keys using the Amazon infrastructure. I'll just use the file system here as an example, but storing encryption keys in clear text is not a good idea. So let's encrypt the encryption keys that we store on disk. We can encrypt them with another secret that we store in a key vault or certificate store on the machine or something like that. So any ASP.NET Core application, in my opinion, should have add data protection and these 3 lines: set application name, persist keys of file system, and protect keys with something, or persist keys to somewhere, protect keys with something. There are multiple options. Pick one that's suitable for your environment. Let's go do that to our application here. Builder.services.add data protection .set application name Copenhagen .persist keys to file system. We'll just use is a directory info actually. The current directory or we can take I think it was the temp DP keys. I probably have a bunch of keys in there already. Protect keys with certificate, and I have this thumbprint is a thumbprint of a certificate that is available on my machine right now. So if we run it once more, and then if we go and check c:\temp dp keys, we can see that we have it in XML format. We have the key here, and it's a cipher value, so the actual key is encrypted using the certificate. This is the public key part of the certificate presented here. The reason I'm mentioning data protection is it's not because you would necessarily use it yourself directly, but there are so many things in the authentication system that makes use of it. So if it isn't correctly configured, then it breaks. I would say that the Duender support, about 30% of our support requests boil down to incorrect data protection configuration. Okay, so we have a final block I want to show you on the demo app, and that is I also have an API, so I can call an API, and I can just see what happens if the API returns challenge. We have 401, as we said. Forbid, what will it return? 403, yeah. And we can call so we can call authenticate. This means that we ask the API will call authenticate on the bearer token that it received, and it will return the contents. Authenticate failed. I'm not logged in. And to get an access token, I need to work with identity server. Authenticate failed. So we can now see that this is the contents of the access token that was sent to the API. We have the issuer, demo@duendersoftware.com, and a bunch of other stuff that is available in the access token. So we can have the same API even in both. We can actually check the API what is defined as. You can see here that we just have it's the same. Add authentication and then add JWT bearer. It's just one scheme. We don't have to specify the default scheme. It's this one that is the scheme. Okay, that is. Let's continue here. So to summarize, we have an application We set up cookie-based sessions in our application. We integrated with an upstream provider. We did some top-secret authorization rules through our policy. And we called an API using a bearer token and saw that the API uses just the same authentication system. That is what I had. So any questions? Everything is crystal clear, right? And I still feel that I mean, Dylan ended his talk by singing a song he had written, which was actually working code. I'm sorry, I'm not anywhere near his level at this. But I hope it was informative, and if there's anything you want to ask, I'll be around today and tomorrow, so just grab me. So thank you for having me. Yeah, so the NDC evaluation system is that grab a green, red, or yellow slip of paper, drop in the box. So if you were happy, a green. Oh, I forgot to say also that the example code I used, it's available on my GitHub account. So the repository is there.